Yesterday we worked on expanding the log. Today we're going to talk about condensing or making logs into a single log, and we'll also talk about a formula called the change-based formula. So yesterday we talked about expanding logs, and today we're going to talk about changing them back into single logs, or in the book they call it condensed logs. Okay, and so there's basically just two major steps that we're looking for here in terms of sequencing this. So if you're going from expanding an expanded form to a single log form, then the first thing we're looking for are anything that has the powers. And remember, those are the numbers that are in front of the logs. And the second thing we want to do, from left to right, you want to go ahead and deal with the quotient property and the product property. So if you follow these steps, and again, just kind of think about going backwards on condensing them into a single log. So taking a look at these two problems on your worksheet that the substitute should have passed out to you, again, the first thing I'm looking for to see if there's a number in front of these logs. In this example, there isn't any. Then the second thing I'm going to do is go ahead and condense them. So I'm just going to go ahead and write log base 3. And then depending on the sign in between the numbers, I'm going to go ahead and either divide the numbers or multiply the numbers. We kind of know going backwards, if I see a plus sign, it came from the two numbers of the logs being multiplied. So again, I'm just going backwards of the rules. So in this case, because there's a plus sign between these logs here, I'm just going to write the first two as 4 times 2. And then again, I'm just going to go from left to right. This one also has a plus sign, which means that this number was multiplied with the stuff in the front. And go ahead and simplify the numbers of those logs. Okay, and we'll find that the answer is log base 3 of 16. So looking at example B, again, I'm looking to see if there's a number in front of the log. This one has a 3. So the first thing I'm going to do is actually put the 3 back with the variable there. And then I'm going to go ahead and use the quotient or property, product property to go back and condense this into a single log. So again, I'm going to go ahead and write log. And remember, if you don't see a base, that means it's automatically 10. We're taking the 4. Because this is being added with this, that means that the 4 and the extra, the third, was multiplied. And then moving on here, because there's a plus sign here, that means this number got multiplied to the stuff in the front. And again, let's kind of fix that up a little bit, and that would be your final answer. So here are some more examples. What you can do is the sub can stop the video here, and you guys can try this on your own, and then resume it. I'm going to go ahead and let this run so you guys can see what it would look like if I actually do the work and write it out. So you can see for the first one, I moved the 1/2. And then the first one got multiplied, and the first one here got multiplied, and then the last one here got divided. So that's the way I would actually write it. So in this case right here, again, I saw the 2 right there, so I put it back with the log of the number. And remember, ln is log base e. There's a minus sign in between here. So the first thing, let's kind of go back here slowly. So the first thing I do is write x squared, but because there's a minus sign here, that means that this number was divided with that number, so I'll just put it under the x squared. And then going in this order, this 6 was multiplied to the number in the front, so I'll just put it with the x. Okay, so that's being multiplied, and then if we keep going here, just fix it up a little bit, we get ln 6 x squared to the third, 6x squared divided by 3. And then from here, notice that 6 and 3 can be divided, so it'll be ln x squared. For the next example, again, I see the 3 here in the front, the 2 in the front, so I'll go ahead and put that in the back of the number of the log. And again, in this order from left to right, I'm going to go ahead and either divide the log of those numbers, this one, this one, this one, or this one, or multiply depending on what the sign in the front is. So since the first one's division, I'm going to go ahead and, subtraction, I'm going to go ahead and divide those. And then the next one's addition, so that means it was multiplied. And the last one's addition, so it was multiplied. If I go ahead and fix this up, we get something that looks like this. And again, because it is a fraction, I want to go ahead and reduce variables or terms that are divisible. So my final answer for this one is ln 2 times the quantity x plus 1 to the third, all divided by y. So this is a new formula that you want to remember. It does actually come from working out problems that are kind of similar to this. So as mentioned before, the log that's on the calculator, the log key that's on your calculator, only is for the base of 10. What about logs with other bases? Well, you can actually change it to this particular formula where you can actually take the log of A and entirely divide it by the log of C. C is representing the base that's actually to that log. Okay, so for example, this is how it came about. We know, for example, that log base 2 of 8, we know the answer here is going to be 3. Okay, but let's say we don't know that. According to the formula, if I punch in my calculator log 8 divided by log 2, you should see on your calculator that it'll say 3. Okay, now if you don't get the 3, remember you do have to punch in the key for the logs once for the 8th and once for the 2. So make sure you type in the log twice, okay? But it comes from basically problems like this. Again, if we start from the beginning here, log base 2 of 8 is equal 8. We change it into an exponential form, okay? There is a rule where you can actually put in log to both sides of an equation. It's kind of like adding numbers to both sides, subtracting numbers on both sides, the properties of equality for equations. If we do this, again, going to the properties that we just learned, I could put this little x here in the front. Okay, so it looks like x log base 2 equals log 8. And then from here, because these are being multiplied, I'm going to divide out log base 2. So you can see here that this particular result does equal to the one in the formula. And again, if you do type it in your calculator, it'll say 3. So there are examples that actually interchanges with the property of the logs and using the change-based formula. Sometimes you actually have to prep up your your question or equations so that you can actually use the change-based formula. So for these kinds of problems, most likely you'll be giving a table that only goes up to about 20, 25, somewhere around there. So log base, 2, log base 3, log base 4, and the table will have a decimal approximation. And again, we'll talk about that when I come back and see you guys later. But like for example, the first one's not too hard. If I take a look at the first one, I see that there's base is 7. Okay, so I can rewrite this as log 12 divided by log 7. And this stuff you can actually probably look up on your calculator as any other number. But again, we're asking you to use the properties of the logs. Okay, so keep in mind that the table that you'll be given will only probably go up to log 20. Okay, and those are the numbers that you can use. So in any case, if we go ahead and look up the decimal approximation, you guys can, use your calculators and do this, and you guys can get this approximation on there. If you go ahead and divide it, then you get 1.2770. So what that means is that since this is the answer for the exponent, right, if I go ahead and check this, 7 to the 1.2770 is about 12. Okay, and you can always check this on your assignments or even your examinations. Now G is a little bit more challenging. If I take a look again, I won't have anything like this 1.25 on my table, although your graphing calculator will be fine. It'll actually give you the decimal approximation. But again, most likely you'll be working off a table. 1.25 will not be there because there is no decimals of a log on those tables. Okay, so again, using the properties that you guys learned, expanding them, what we can do here is change 1.25, okay, into a fraction. Okay, so we kind of know, our decimal rules here. 1.25 is the same as 125 divided by 100, okay? And then I'm going to go ahead and I can actually use the quotient property by subtracting the two logs, okay? And then from here, again, there is not going to be any numbers that goes up to 125 or 100, so I'm going to go ahead and change that into 5 to the third, and I'll change the other one to 10 squared, okay? And again, we see that there's little exponents here, so I'll move that to the front of the logs. Okay, And then now I can go ahead and with this part here and this part here, I can use that change base formula. But you should recognize something here. Remember, if you have a log of the base and the log of the number, if they actually match, if you remember, that's just 1. And for the other one, we're just going to have to set that one up. Okay, but again, log of 10, again, one of those shortcuts there is just 1. Okay, and then looking on the table or even your calculator, and please keep in mind if you use your calculator, you want to go up to 4 digits. Okay, you have something like this. So if you crunch all the numbers, you'll get 0.1386. And again, if you check it by doing 5 to the 0.1386, it will give you 1.25. H is even harder, okay, because this requires a lot of steps to set it up before you can even use change base formula. So again, looking at this one here, I'm going to change that 0.0005 into 5 divided by 10,000. Because this is being divided, I'm going to separate it by putting subtraction in between and taking the logs of both numbers. Again, this one here, I'm going to change it to 10 to the 4th, but again, at the same time, I will go ahead and use the change base formula at this time. And then looking on the bottom here, remember, there is not going to be a 1/3 on your chart, okay? Although you probably could type it in your calculator. But again, we want to practice the properties that you used. So because this number is being divided, I'm going to go ahead and separate it by subtraction. And it's true for both sides because they're both the same numbers. Okay. Oh, and then by the way, I am putting the 4 in the front right now just to save us a little time. So remember, there's a 4 here. I'm just going to put it right in the front. And then from here, I'm going to go ahead and change them all into the decimal approximation because again, you guys can see here, these numbers that are on your logs is actually will be available on the chart. And again, the chart most likely will only go up to like 20. Okay. So anyways, log of 10, base 10 of 1, remember that's a little shortcut that equals to 0. The other one is 0.4771, and obviously the bottom will be identical on both sides. Okay. And then we're going to go ahead and crunch the numbers here, and you'll find out that the answer you'll get is 6.9189. Okay, so please do the homework that is on the assignment sheet. That hasn't changed a bit, and we'll see you later.